The table below gives the values of the differentiable functions f and g and their derivatives at x equals 2. So what this table is basically saying is x is 2. It's not your normal table. It's a little bit different, but this one is really saying this is f of 2 equals 7, because f of x, when you plug in 2 for x, is 7. All right, so this one's saying f prime of 2 equals negative 2. This one's saying g of 2 equals negative 5. And this one's saying g prime 2 equals 3. Just want to make sure you can understand the table. It's a little bit different. It's not your normal table. It's just saying x is this, and so it's saying for each of these plug in the respected 2 value. Okay, with that said, h is this big mess. Find h prime 2. So to find h prime 2, we first have to find h prime. So to define h prime, we have to realize is this is a product rule. You're going to multiply that times that. So here we go. So h prime of x, the derivative of h, is equal to, we're going to take the derivative of 3 f of x, which would just be 3 f prime x, and the derivative of negative 1 is just nothing, disappears. So that is my first piece. All right, and then I leave the 2 minus g of x. All right, then we put a plus, and I'm going to leave the 3 f of x minus 1, and then I'm going to multiply by the derivative of 2, which is 0, and then I leave the negative, because that's like a negative 1 in front, and that's g prime x. The derivative of g is g prime. So there is my big mess. Now I could try to simplify all this, but why? You don't need to simplify. You just need to start plugging in stuff. So here we go. h prime 2 is equal to 3 f prime 2, all right, times 2 minus g of 2, plus 3 times f of 2 minus 1, times negative g prime 2. Okay, so let's see what happens here. So h prime 2, what do we get here? Well, this would be 3 times, what's f prime 2? F prime 2 is right here, so that's negative 2. So I'm going to replace that with a negative 2. And this is going to be 2 minus, what is g of 2? G of 2 is right here, negative 5. So this would be a negative 5. Plus 3 times what? Minus 1. Well, what's f of 2? F of 2 is right here, so f of 2 is 7. So this would be a 7 right there. And the opposite of, what's g prime 2? What's a g prime 2? G prime 2 is 3, so the opposite of 3, you just put opposite of 3. Okay, we're getting closer, we're getting closer. So h prime 2 is equal to, this would be negative 6. All right, this would be, right here, 2 plus 5, which is 7. This would be 21 minus 1, which is 20, and the negative 3. All right, so right here, multiply these two and multiply these two. What we're going to get here is that would be a negative 42, and that would be a minus 60. So my answer here would be negative 102. So the answer we're looking for is negative 102 for h prime of 2. So don't get scared with these kind of problems. It's not as bad. It just takes some practice getting used to them. You're taking derivatives with a whole bunch of f's and g's and h's and stuff. You can do it. Hang in there. Let f be a differentiable function such that f of 5 equals negative 2, f prime 5 equals 1. If g is the function defined by this, what is the value of g prime 5? So we first have to find the derivative of g and then plug in 5. So let's find the derivative of g. So g prime x is going to equal to, well, there's two pieces here. We're going to take the derivative of both. So first take the derivative of 3x, which would be 3, leave the f of x, plus leave the 3x, take the derivative of f of x. All right, so we took the product rule of this right here. Now we plug in 5. Now you could try to clean it up first, but I'm just going to plug in 5. So g prime of 5 is equal to 3 f of 5 plus 3 times 5 times f prime of 5. Next, well, what's f of 5? It says right here, f of 5 is negative 2, and it says f prime of 5 is 1. So we replace those for the next step. So we have g prime 5 is equal to 3 times f of 5, the values above say that's negative 2, plus, that'd be 15 times f prime of 5 is 1 from above. So now we have negative 6 here and 15 here. So what do we get? Well, that would be negative 6 plus 15, which, what does that equal? That equals 9. So my answer is 9. What is the value of the derivative at 5? It is 9.